Yeah, g'day, Mark here, and welcome back to my workshop. Now, I'm a pretty lazy machine buyer. Like, I bought my lathe sight unseen over the internet during COVID, and when I bought my surface grinder, I didn't actually ask whether it was metric or imperial. It's imperial. So I think we'll start putting a DRO on it so that I can actually read the dimensions in a number that I can understand. Now, my mate Stefano in Chicago, the designer of DrDro, has been hounding me for about a year to put a DrDro on the Clarkson, put a linear scale on the slide, and slave it to a stepper motor to drive the universal head to be able to grind spiral flutes. But so far, I haven't got around to it. So once he saw that I had bought an imperial surface grinder, Stefano kindly offered to send me a kit set of DrDro parts so I can put a digital readout on this machine. Thanks very much, Stefano. Mail time. It's one of those old-fashioned Dymo clicky sort of lettering things. Cool because you can use them for castings. There's something kind of fun retro about these, isn't there? Okay, so this has all come in from Chicago. Oh cool, he's made some cool boxes for this stuff now. So this is a DrDro control board, a Raspberry Pi, which I think he already programmed for me, which is nice of him. This is the power supply hat, which goes on the Raspberry Pi and powers this whole system. This looks like it's going to be a lot of fun to put this together. This is the screen for my DRO. It's a 10-inch touchscreen and it's designed that you can mount the Raspberry Pi directly on the back of it. Also in the box, there's a few bits and pieces we need. The first thing I'm going to do is just plug it into my laptop to see whether it actually works. They give you an HDMI cable and they give you a USB micro cable. I really look forward to everything becoming standardized on USB-C because I hate everything that's not USB-C. Good. Monitor's working. That's all I wanted to test there. Right, next up, we need our Raspberry Pi. This one's a Pi 4. There's some software you have to load on it with an SD card. Luckily in this case, that was already loaded for me by Stefano. Thanks very much, mate. Looks like you need some standoffs there. They're in the little baggie. Right, now before this gets screwed down, also in the baggie are these little connectors. So we need a full-size HDMI to micro HDMI, that's this one. And then we also need a USB to full-size USB for this side. This one's for the signal and this one's for touch and power. So next up, I got 4 standoffs from Stefano as well. So these guys lock down the Pi. So this is the power hat, which does the power supply and gives us easy communication with the main DRO module. There are 2 connectors here. One's for the positive and negative power terminals, and the second one's for the serial communication with the DRO board. So these just slot in together. Then slot into here. Right, now I can press this edge connector down and it gives us the right height for soldering. Right, now I can pop it off and do all the other parts of it. Right, well that's all the soldering that's necessary. These little screws came in the monitor box. A lovely integrated design. Now at this point we wired up the Raspberry Pi, the monitor and the DrDro unit, but unfortunately the Raspberry Pi was dead. EMI problem or something. Now Stefano thinks he can fix it, so Luke's taken that over to Chicago with him. I'll see whether he can fix it or whether I just have to get another one of those. But in the meantime, let's move on with actually installing the slides. Now my mate Luke has got 4 or 5 of the DrDro units installed on his machines. So when he dropped in on his way through to Chicago last week, he sort of pointed out how he had installed all the stuff on his Jones and Shipman 540. And that was great motivation to finally get stuck in and get into this job, because it would really improve the usability of the surface grinder. Mail time. Cubitron scales with 1/10 of a micron resolution. Now, am I going to make parts to 1/10 of a micron? Of course not. But they always say that you should use 1 order of magnitude higher resolution than the accuracy and repeatability that you sort of would like to achieve. I'd like to think I could probably on a small part reach 1 micron resolution if I really tried. So there's 2 scales. This is the cross-slide scale, 170 millimeters of travel. And the vertical travel of the grinding head is 280 millimeters. So this is the closest standard scale longer than that. So there's covers, some standard mounting brackets. Not sure if they'll work, but hey, they look like reasonably rigid die casting, so that's a good way to start. Right, let's start looking at installing these linear encoders. This is the short one. It's for the cross slide, forward and back. I've had a look at both sides, but on the advice of my mate Luke, who's already installed one on his, I'm going to put it here on this side. Last summer, I picked up this coolant tank, which is from a lathe. Now, you're probably wondering what that's got to do with installing the DRO, but the coolant return goes out this corner, coming out here, pretty much directly above where the DRO is going to sit. That fluid return has to get back down to the tank, and that point there can be anywhere in that space. So what's normally done is a gutter is put along the back here to catch flow anywhere along the table's travel. And then all you need is a short catchment from the bottom of the gutter over the forward to back travel distance. Why am I thinking about the gutter along here when I need to be concentrating on mounting the slide under here? If you look at these 3 bolts here, this on the end of the saddle is just a bolt-on casting which catches the oil. And so in discussion with Luke, seems easiest to unbolt that, make up a intermediate steel plate which gets sandwiched in between here and the saddle, and use that both as a carrier plate to mount to my slide, and at the same time I could extend that with a bracket to pick up my gutter. While it wouldn't kill me to put a couple more holes in these heavy castings, if I can pick up existing holes, I think I will. Like for example, there's 2 threaded holes here that I might be able to pick up to mount this measuring head. Now those existing holes we threaded Whitworth, but luckily Andy Pugh sent me a care package of Whitworth screws and bolts from the UK, which was very nice of him. Maybe I can find a couple, maybe these will fit. Perfect. Well, these Cubitron scales I bought do come with attachment brackets for mounting them, which are quite nice and die cast. I really don't think I'm going to make them work on this build. I think I'm going to need something a little more complicated. But I think I'm going to start with the drain and the gutter. This is going to need some sort of a blanking plate or a pickup plate over here with some sort of an elbow coming out of it. I found that fitting, that's kind of roughly the right sort of size and shape. Not sure if I want to use copper and steel. Maybe you want to keep the copper ions out of coolant. I'll think about that. Maybe I'll find some steel elbow to do that job. The gutter's going to need to be cut away enough to allow it to slide underneath there without touching. Probably want that tube to come out a wee bit further as well. So I guess I'll be chopping away part of my square pipe. If you're uncertain of what to get your loved one for Christmas, surprise them with some 3M Cubitron grinding discs. These things are amazing. I bought them from Amazon. I'll leave a link below. They last for ages and cut much better than their normal cheap ones. I've now got 2 end pieces to weld onto my gutter, but I've also got this one hole I need to fill. So I'll just clamp a bit of copper on it and weld up that. If I was a better welder, I could probably do this without the copper, but I'm not. I used some of my homemade citric acid rust remover and just poured it in and let it sit for about 10 minutes. And you can see the tide line where the rust remover worked and what was above it. So the stuff's obviously still nice and effective. Now the gutter is also going to need a drain back down into the coolant tank. So I'll just weld a bit of tube on here. I need way more practice at how to weld around a pipe flange, but luckily in this case, this welds on the bottom at the back of the machine, so nobody's ever going to see it. Right now, the last thing I want to do with this gutter is just weld a couple of studs onto it, just to make it easier to assemble the thing. Well, I obviously didn't take any footage of welding those studs on, but that doesn't matter. Now we move on to making the flange to hold the drain. For the drain, I went to the hardware store and just went looking through their fittings. So the one I found is 12.5 millimeters by I think 3/4 of an inch. So it seems to fit nicely. Right, now to connect these, I'm going to braze them. I'm going to need some flux on there. Just go around it and just give a nice little layout of flux all around the base. Actually, I should probably put a bit of flux under it as well, in the joint. Keep the flux open so I can dip my metal in it. So the filler rod I'm using is very expensive, high silver content brazing rod, but it melts at a nice low temperature, so it works with just propane, because I don't have any oxygen equipment. Now this is going to need a seal underneath it, and I think that's one of the killer apps of 3D printing. Look at this, took me all of probably 2 minutes to whip this up in Onshape and then print it out in TPU, and yeah, this is just so easy. Especially the side that was down against the bed of the printer, you wouldn't even believe it's a 3D print. Right, well I gave that a hit with the wire brush and cleaned it up and bolted it in place. I am still going to need to bring down this lip a bit because it's a bit too high at this stage, but it's looking good. Mail time. Oh, so this is my new filter unit. I didn't really picture how tiny this would be. It's supposed to replace this one, which has lost its valve at the bottom, but yeah, I might need to think about that. This box is a familiar tale. I replaced the speakers on my MacBook Pro about 1.5 years ago, and it's time to do them again. It's just the way it is, because I use my computer down here in the workshop, and there's normally grinding dust and all sorts of other crap to be picked up by the magnets of the speakers. After a while they get fuzzed up and start sounding like crap. They only cost about 25 bucks, and it's an hour to replace them, so it's become a maintenance item. Up until now, I've only ever used rags in the shop, and I figured it was about time I put up some paper towels. Seems like a much more efficient way of doing things. And this is a set of the tiny little ER11 collets. Just the little cute ones. Some time ago, Christian gave me this lovely little tapping head for my mill, which is far more practical than the comically large Tapmatic, which I use for bigger taps, and it takes ER11. So it was about time I got some. Right, I found this model on the Thingiverse. Actually had a lid for it, but I don't really need a lid because it's going in a drawer. I like the way he's integrated the two Imperial ones into the system. Anyway, enough mail time. What was I working on? So with that now done, I can now pop this drain thing off and take a look at measuring up and making up bracketry, both to pick up the support for the gutter and also start looking at brackets across to my linear scale. And of course oil on the floor. So this is an aluminium component. I guess what I should probably do is free it up from its Smurfshit paint in preparation for it getting a decent colour. Right, it's time for making brackets. I really like transfer punches. You can get a pretty cheap set of these off Amazon. I'll leave a link. Now I need to put some slots in this to pick up the bracket for my gutter, and then I can start looking at how I'm going to connect this across to the linear slide. So I've now got this bolted into place. Just make sure there's no interference anywhere. Alright, and does the gutter angle down to the drain? Yes, it does. Now I've got one part of my bracket captured here. I've got a second part of the bracket here bolted onto my scale. So now all I got to do is just connect them. I'll put a bolted joint on here. So it looks like it needs to be about 6 centimeters, but it's going to need a joggle in it, which is going to need to be about 5 millimeters up. Right, this plate is 2 millimeters thick, so it's beyond the capability of my homemade bender, but let's see if I can give it a good bashing in the vise and see if I can make a joggle out of it that way. I'm sort of trying to use this to keep the bend down at the bottom rather than just making a whole dented mess up the top. Now I need a joggle of 5 millimeters, so I think I'll slightly overdo it on this first bend, and then I can still determine where I put my second bend to bring it back. Now with a joggle, the first bend's always the easy one. The hard one is, of course, now flipping this over and bending it back without turning it all into a big dented mess. I really should make up one of those sets of dies that you use in the vise for bending. Especially for smaller items like this, it would be really quite handy. Guess this is not ideal for this kind of vise because all of the force I'm applying is going into the lead screw. Well, that joggle actually came out quite nicely, and it seems to be just under 1/4 of an inch, which is what I wanted, so great. I next need to cut the adjustment slots for the bolts. So if I go in 3/8 from each end, so that'll give us about 5.5 inches between centers. That's good. And now I'm going to need a couple of long adjustment slots here. You know, I always think it'd be nice to have some setup where I could do these slots really quickly on the mill, but I really don't. I'd have to program them, and so I don't. So I just end up center popping holes and doing them manually. My 2/2 of bracket are now ready to get welded together. That should hold together well enough. Now, while offering this up with these brackets, I realized that I made this bracket a little bit too wide and I'm going to need to shorten it. Now, luckily, it's super obvious which direction I need to shorten it in. So therefore, there's no real danger that I could, cut the wrong end and then have to weld it back on or anything. So that was lucky. So I've got movement backwards and forwards there. I've got movement up and down, which I've tightened in the slots of the scale. So it looks like I've got clearance under here. I can still easily get to the end stop adjustment screws for my kick-out mechanism, which is here. I'll just wind this back and make sure there's nothing I've overseen. This is where it really helps to do stuff like that with welded in studs. I only need this one spanner. Don't have to worry about trying to put anything else on the top of it. The reed head, even if it's most extreme other end of travel, is not going to hit anything. So now I need to make up the bracket which connects the reed head to those two bolts. Okay, with it test fitted, it needs some tweaking because it's off at an angle this way. So it needs both more joggle to bring it out a little more at this end and then straightening it this way. So I gave it a light tweak and now it looks like it's just nice. Now before I can transfer the holes from the reed unit through into the bracket, I'm going to need to align that a bit. Right, bit of bumping backwards and forwards, and now that vertical adjustment seems pretty good. Now the horizontal alignment's also roughly there. I'm really happy with how my adjustments have turned out. To adjust it level horizontally, I've got this screw and this screw, which are easily adjustable. And to adjust it horizontally, I've got these two screws, also easily accessible. So that worked out very well. So with that, I can drop in a couple of wedges just to support that angle while I transfer punch the holes. Well, now that I've got all my brackets made up, I just need to prep them for painting, which I won't get done this week. That can be in the next video. Okay, let's go and put all those bits through the sandblaster. Do a bit of a clean up. I'm really looking forward to getting this DRO working because I think it's going to be a big game changer for this surface grinder.
Why does the bracket look like that?
It's complicated.
Is that one of your measure twice before you cut once moments?
Right, let's do a trial fit up and see how it looks. Between the gutter and the drain and getting all the cross-slide bracketry and linear encoder mounted, pretty happy with this week's work. The next step is installing the vertical slide, which goes inside the main housing, so it's going to be a bit more challenging to install. But hey, thanks a lot for watching, and stick around because the algorithm's now going to offer you a video up here, which is just the right one for you. I'll see you next time.